We're going to continue on with our grade 9 review. So today we are going to be looking at forming ions. So before we look at forming ion, let's take a look at what an ion actually is and how it's different than what we've been looking at. So a neutral atom has the same number of protons and electrons. So it has the same number of positives and negatives. Those positives and negatives cancel out, and it's said to have a neutral charge. Those neutral atoms were what we were drawing in our Bohr-Rutherford diagram because our number of protons and electrons were the same. Atoms will actually lose or gain electrons to be called ions. So you're either going to gain an electron or lose an electron. By gaining an electron or losing an electron, it allows you to have full valence shells, and it allows these ions to be more stable. So ions tend to be more stable than neutral atoms. Ions will follow something called the octet rule. So think about the word oct, sounds like 8. Outside of the first shell, it's considered to be, an atom is considered to be full if it has a 8 electron outside shell, right? So 8 is considered to be a full shell outside of the first shell, and that's what the octet rule states. So the octet rule is that atoms are more stable when their valence shells are full, like that of noble gases. So all atoms want to have a full valence shell. They do so by gaining or losing electrons. We have two different types of ions, so you can see both of these terms have ions in it. If something is a cation, it's said to have a positively charged ion. If something is said to be an anion, it's negatively charged. In order for something to be positive, it must have more positives than negatives, so it must have lost electrons. For something to be negative, it must have more negatives than positives, so it must have gained electrons. So anions will gain electrons, cations will lose electrons. Notice that we're only talking about the gain or loss of electrons. Electrons are the only thing that move in this case. You cannot gain or lose protons. That's because they're in the nucleus. The number of protons actually defines what an element is. So when we're looking at ions, we're only looking at the gain or loss of electrons. Ions are formed by gaining or losing electrons. In the number of valence electrons that they have is going to determine whether or not you gain or whether or not you lose. So essentially, ions are always going to do what's easiest for them. So if you have less than 4 electrons, if you have 3, 2, or 1, it's easier to lose to have a full outside shell. If you have more than 4, it's easier to gain than to lose. So you're going to gain electrons in order to have a full outside shell. Notice that 4 is kind of the tiebreaker here. We typically don't see ions form with elements that do have 4 electrons. It can happen. It's something we're going to see more in grade 11 or 12 chemistry. So in terms of grade 9 and 10, we're only going to be looking at atoms that have 1, 2, or 3 valence electrons. They're going to lose electrons. Or atoms that have 5, 6, or 7 electrons, they're going to gain electrons. Ions can also be represented as Lewis diagrams. The only difference between Lewis diagrams for ions and regular Lewis diagrams is we are going to use square brackets. So square brackets are kind of the international symbol of ions. This is going to carry through into senior chemistry. So anytime you have an ion, you want to tell me it's an ion with square brackets, and you also want to tell me the charge. We're going to look a little bit more on how to calculate charge as we do some examples, and then I'm going to remind you of the trend of charge that you learned in grade 9. So first of all, we are going to look at a sodium atom. So a sodium atom here, this is our sodium atom. Our sodium atom has 11 electrons. So it has 2 in the first shell, it has 10 in the second shell, and it has just 1 lone electron on the outside shell. We call this its valence electron. Now, if you take a look, this valence, this outside shell, is not full. So sodium, to become stable, is going to want to form an ion. Our question is sodium going to lose an electron, or is it going to gain electrons? So let's think about what's easier. In order for this outside shell to be full, there's 2 options. Sodium could lose this 1, therefore the outside shell, the second shell, will be full, or sodium could gain 7. So you want to think about what's easier. Is it easier to lose 1 or gain 7? The answer, of course, is to lose 1. So in order to form an ion, sodium is going to lose 1 electron. So we're losing 1 electron. What's that going to look like? It's going to look like this. So sodium has now lost that outside electron. So now this is the ion. Remember, in order to tell me that it's an ion, you do want to use square brackets. So you'd have square brackets on the outside. And you also want to tell me charge. So one way that you could calculate charge that's always going to work is you could take the number of protons, 11. Remember, protons have a positive charge. And you could add to it the number of electrons. So we have 10 electrons if I count. Electrons have a negative charge. And if you add these together, you're going to get a +1. So sodium's ion is going to have a charge of +1. Now, if you don't want to do the math, this is kind of the long way every time, you could actually just think about it. I've lost 1 negative. If I've taken away 1 negative, I must have an overall positive charge. When you're writing this as well too, when you're recording your positive value, notice that I put +1 over here. You are allowed to write just plus. That's actually a short form by most chemists. You don't have to show the 1. If it's a charge of 2 or a charge of 3, you do have to show the value. So we now know that sodium has an ion of Na and it's considered to be plus. Now let's take a look at chlorine. I actually want you to pause the video for a second and I want you to try to determine the ion of chlorine and how it's going to be different than the atom of chlorine. So let's walk you through this. Chlorine, we know this is an atom because if you look on the outside, you don't have that full valence shell and the number of protons and electrons are equal. So we have 7 in our valence shell. Not full yet, so we are going to gain or lose an electron to become more stable to form an ion. We have to ask yourself, is it easier for chlorine to gain 1 or is it easier for chlorine to lose 7? Obviously, it's much easier for chlorine to gain 1, so chlorine in this case is going to look like this as an ion. Now remember to tell me it's an ion by including our square brackets. And you also have to include the charge. So you could do this a long way, take the number of negatives, take the number of positives, add them together, or we could just think about it logically. Chlorine has gained 1 negative. Since it's gaining 1 negative, it must have a charge of -1. Again, you could just write it as negative. So that's how you draw ions. All we're going to do now is we're just going to talk about some general trends for ions. So this is going to work every single time. Now, we don't necessarily, moving forward in this unit, care about drawing ions. We more care about the charge of ions. It's very important in our next lesson for you to be able to determine the charge of an ion essentially right away. So we want to think about some of the rules. Overall, metals lose electrons. So metals are always going to lose electrons, therefore they're going to have a positive charge. That positive charge is actually going to be equal to the group number. So what that means is anything in group 1 or column 1 is going to have a charge of +1. Anything in group 2 or column 2 is going to have a charge of +2. And anything in that group 13, because remember we're skipping that middle box for now, I'll get to the middle box in a couple lessons, is going to have a charge of +3. Non-metals gain electrons, so they're always going to have a negative charge. They're going to have a negative charge equal to their group number. Equal to 8 minus their group number. So let's think about, right over here, our halogens. Our halogens are group 17. So we're going to have group 17. Group 17, we're going to call it 7. Group 17 is going to have a charge of -1. Group 16 over here is going to have a charge of -2. And over here we have group 15. Group 15 is going to have a charge of -3. So you can see we actually have this counting up, 1, 2, 3, and we have this counting down, -1, -2, -3. Now notice that the last column here, noble gases, we ignored. We ignored it because noble gases are actually already full. So they're not going to form ions, so they're not going to have a charge. They're already neutral and stable as they are. We also ignored this group 14 column here, which has carbon in it. That's because it has that tie, those 4 valence electrons. So they don't tend to necessarily form ions. So we're going to ignore this column as well too. So as long as you remember the trends of +1, +2, +3, and then -1 for your halogens, so chlorine's group, -2, -3, you can figure out the charge of ions really easily at a glance. This is going to be really important when we look at ionic compounds, which is where we're going next. So that's actually it. That concludes our review of grade 9 chemistry. That's everything that you should need to know to move forward. So now we're ready to start brand new chemistry in grade 10.